Ampacity. So everybody's guys at 310.16 or 310. Just let's go to 310. I want you to highlight a few things that I think when I teach it when I teach code update, I make the people highlight them all the time. When I teach exam prep, I also walk people through them. Um, when you guys grow up in and you become sizing medium voltage, I want you to highlight electrical ducts and thermal resistivity. I know, Chris, you asked me about the ducts, underground ducts that we were pulling in. Um, Later on, we're going to talk about ducts. What is a duct? A duct, underground duct, could be a rigid conduit, PVC, EMP. So this is a little bit talk about electrical ducts or raceways, rounded cross-section that are suitable for use underground. So they define what is a duct. Later on, you're going to see why this is very important. If you are to expand in your career, you're going to talk about thermal resistivity. If you put conductors, guys, so these, if you put the ducts and the thermal resistivity, if you put conductors underground, depending on the thermal conductivity of the underground, the conductor can carry this amount of amps or lower amount of amps. So just pay attention to these two terms. That's all what I want to say about them. There is a software that calculates them. Okay, use is permitted. All the calculation in chapter 4, the wiring methods can be calculated. There's a few things you have to pay attention to: dry location and dry, damp, and wet. If you guys have not highlighted this yet, if you're in the wet location, right in here, here's all the wiring methods that you can use in wet location. If you're in dry location or dry or damp location, all these are your wiring methods that you can highlight. So please highlight. We all know that, but this is where you can find in the code where it tells you that THHW or THWN are actually for wet location. Any comments about these? So these are very, very important to understand the locations of the cables. Which one can be used in dry? Wet location is the most important thing, is wet location. Dry and damp. Shielded, not for you yet at this point.
Can you back up a little bit?
Yep. Oh, the article, I'm sorry. 310.10. Use is permitted. Okay, so keep going in here. I want to highlight a couple of things. Conductors in parallel. Conductors in parallel. Do you guys remember, Ashley, we kept saying, what's the smallest conductor that you can carry in parallel? Anybody remember that?
Yeah.
1 off. Can you highlight that one? This is the single most important. It will tell you what conductor do you need to carry. The smallest conductor that you can carry in parallel is 1 off, right? Now, exception right here. This is for those of you who are going to sit for a journeyman exam. You can parallel this than 1 aught. You can parallel this than 1 aught, but only for control and signals. And I'm going to stop right there. For us, most of us guys are power, less than 1 aught shall not be paralleled, except for control and signals. So if you want to expand on that one, instrumentation and so forth, you can parallel. Okay, so that's the paralleling. Oh, I'm sorry. Yeah, 310.h. Continue with 310.h, guys. The conductor. 310. Where was I here? 310.h1.
So there is no dot.
310.
So 310
Dot. No, 310.10. 310.10 H1. Thank you. 310.10 H1. Okay, characteristics of conductors that you can parallel. We all know that. You guys know it with Chad, right? The characteristics of the conductors are the following: the same length, it's going to be the same material, the same size, the same insulation, the same termination. And if you have a conduit, you can add also a conduit. Number 6, conduit. If you put them in a conduit, they have to be the same conduit. Okay, everybody knows that? So please highlight these directly into the code. Directly into the code. Okay, so parallel conductors, and they apply for the neutral, the ground, and everything else. All the conductors that you can parallel. Okay, separate raceway ampacity calculation. For art, let's say equipment ground conductor. 102. This is really interesting. Equipment bonded conductors. Just highlight this one for the time being. When we have an equipment grounded conductor or bonding conductor, you size it based on every.
Can you give us the article, please?
Uh,
Run us through that.
This will be 310.10 H6. H6. No problem. Okay. Ampacity conductor. Ampacity conductor, guys, interested. This is where 90% of you guys will spend your career. Look at the voltage that they use, 0 to 200 to 2000, 0 to 2000. You can use the tape, and here's what I want, like the advantage of the engineers. A lot of people don't know that. You can use the table, right? Use any table, no problem. And under engineering supervision, you can use a different method. Very important. That's why the engineers can get away with a lot of stuff by undersizing things. You can use the tables, or under engineering supervision, you can use a different method. As long as you're you want to sign off on it and put your neck basically on the line. So please highlight that one. It always comes handy. Temperature limitations. Temperature limitation. Talk about conductors. Tables. This will talks about where the tables that you're going to be using, guys, in a second here. General use, ambient temperature. Ambient temperature correction. Ambient temperature correction shall be corrected according with the table, or shall be performed under the following calculation. When you do ambient correction, I always highlight this one, guys. When you do ambient correction, you're going to use these two tables. I'm going to highlight now, or if you're smart enough, you're going to plug in this formula and do thermal analysis. You can use this formula. Most of us guys use the table, but they give you a formula that you can actually do a calculation. If you know the amp at one temperature and the type of the insulation, blah, 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 you can find the amp of the same conductor at a different temperature. We have an amp calc software, Chris, that does the calculation for you based on temperature. The article. Okay, let's go to the article. So these are the most important things. That this article would be, I hate the 310 dot, where are we here? What is it, 310? We're still 310.10.
310.15B2.
310.15 B2. Thank you. 310.15 B2. 310.15 B2. Okay. The second important table, guys, in 2011, we have two derating tables based on temperature. This one is very interesting. You're going to spend 90% of your time in this table. If you have more than, if the ambient temperature is other than 30, plus or minus, then you need to derate. Okay, so let's take this one. Suppose I have an ambient temperature of, let's say, Celsius or Fahrenheit. Let's use a Fahrenheit big ambient temperature right here. The ambient temperature is 131. If I have 100 amp, suppose I have 100 amp conductor. Under normal condition, 100 amp conductor, if the insulation is 90, you can get 76 out of that. If the insulation is 75, you can get 67. If the insulation, God forbid, it's like raw mix, you can get 0.41. Everybody knows how to use this temperature derating. If you have a conductor of 100, you can get the following amps if you put that conductor under these circumstances. Make sense? So that's why, Nick, almost always we use insulation. What insulation? That would justify why we use 90-degree insulation. Can you guys see why we use 96? I got 76 amps here out of the same conductor that I could have gotten 0.4 or 41 amps. One more time. Take a 100 amp conductor that under normal condition you can get 100 amps of it. Put it under this temperature, 131 temperature, right? Ambient temperature. Here's what you can get out of it. 76 if it's THHN. If it's THW, you're going to get 67. If it's TW, which is 60, you're going to get 47. My point is, do you see the gravity of dealing with these derating guys? Why we always use THHN? or XHHW. Any question about this table? So that's what I wanted to highlight this one. And I know this is review allowable, but I don't want you to leave here not knowing it. Cool? Can I have thumbs up, Chad? Yeah, we know how to do this. The last thing could happen to you, go to Mashad Cooley and there's a derating and you don't know how to use this table. Or what does it mean? It will be any question what this means, what this table means. I always want to emphasize one little thing here, Chris. If the temperature is lower than 30 degrees Celsius, here's my 30 degrees. Say I have a 10 or less Celsius, which translates to 50 or less. Minnesota, 50 Fahrenheit or less. Look what happened to the multiplier. What happened? Can you guys see that? I start getting more amps out of the equipment. That's in a freezer, mostly, because you can't maintain a temperature of 50 below continuously unless it's a freezer, right? Because outside in Minnesota, even it gets hot. The ambient temperature, it's not just one season. That's if you're in a freezer, you can make the conductor carry higher if you are wiring inside the walk-in freezers and so forth. So I want you up to this point where here's my favorite. Here's the cutoff. Can you guys from here up, you can carry more amps. From here down, you can carry here less. This is more. I don't know of any engineer who use the more. Usually either less or stick with this. Here's the cutoff. This is the typical. See 111 at 30. At this range, you don't add or subtract, right? So 100 amp, if I put 100 amp in a place with ambient temperature 78 to 86, like in Minnesota for the most part, I don't add or delete.
What determines that? Is there some engineering table regarding longitude and latitude where you pull that number? Or
good point.
Yes?
No, good point. Where would you apply this derating table? You apply this derating table from the mechanical, what the heck do they call themselves? When the ambient temperature. Where do you find the ambient temperature? The ambient temperature is found from a literature that provided by it's somewhere here, temperature limitation, ambient temperature. Somewhere here where it tells you the ambient temperature is coming from ASHRAE, American mechanical engineers and so forth provide I have a copy of the ambient temperature. Every city in the U.S. have an ambient temperature. I believe we are 89 in even city in Minneapolis, 89 ambient temperature that you designed based on. I can give you that one. The ambient temperature is coming from ASHRAE. It's not the highest temperature. It's not the highest temperature, guys. They do a lot of calculation to find it. The ambient temperature. Very good point. Okay, so that's the cable adjustment factors. Let's look at this table, guys. ASHRAE. Here you go. Over Ampacity of P70. Okay. 310.15. And now, of course, when I want it, I can't find it. Let's see. Okay, let's go look at the other one, the other table. Okay. I can give you the copy of that, ASHRAE. Let's go to the second one. Now, when would you use this one? This came in 2011, guys, and confused the crap out of people, that table. This table is used only, the rating table is used only if your ambient temperature is 40 and your conductor is rated differently. Take this, ambient temperature 40. Can you guys see that they add 4 more temperature insulation? The same, I will take the same example, 100 amp conductor rated at, this cable is rated for 40 degrees Celsius. The cable is rated for 40 degrees Celsius location. Take this, the same cable, I'm going to put it in the same location, right here, the same cable. So you're going to get 95, if you use an insulation 250, they call them high temperature conductors. If you use a high temperature insulation, you get 96 out of it. If you use 200, 95. 150, 93. If you use the THHN, the one that we know, you get 84. If you use THW, 76. If you use TW, 50. So this, based on the insulation that you use, you can get from the same 100 amp any of these amps that you can imagine based on what type of insulation are you using. Are you using these insulations or which insulation? Most of the time, Nick, most of the time, this table, can I get you, when do you use this table? Most of the time, this table is used with these insulations. This table is almost always used with these insulations. They call them high temperature conductors, high temperature conductors. When would you use something like this? Probably 5% of your career. The one before, when would you use it? 95% of your career. This is in a place, a furnace room. The furnace room, we use conductor rated for 250 degrees Fahrenheit, Celsius. And if we want to derate it because of the ambient temperature is different than 40, you come over here. Any question about this table? Any question about this table?
One says 30, the other says 40.
Yes, thank you.
So going in, what tells you that we should hit 30 or hit 40?
The Ampacity table that you're looking at. Like 310.15b16, it will tell you if you're using this Ampacity, it's rated for 30
tells you to go
to 40.
Yeah, there's two tables.
Yep.
And 90% of the time we use 1.15 or yada yada.
Yep.
Or we use the other one.
Yep.
At what point do you make that decision?
Based on the conductors that you're using and the ambient. I'll show you in a second. Just you hold this thought for just one little second. We're coming to it. Okay, so that's my derating. If you're putting conduits on the roof, you guys remember that one? No, I'm sorry. This is two tables here. Table number one for bundling. If you're bundling more than three carrying conductors, you can derate. So let's just say I have 40, and I can cut them by, if there are 40 carrying conductors, you cut them by 40. Anybody does not know how to use the bundling? I know we've done that many times. Can I have thumbs up, Chad? We know the bundling. This is just quick review. Right underneath the bundling, there's another table. If you put conductors on a roof, then you have to do it because of the reflected heat. So for example, if I have a conduit, and we talked about this, here's I'm on the roof and I put a conduit right on the roof, and the height of this structure was, let's just pick a number, 12 inches, a foot. So on a roof, so here's my 3.5 all the way to a feet, so I'm right here, 12 feet, and I need to add 30 degrees Fahrenheit to my ambient temperature. So in Minnesota, if my ambient temperature is 89 degrees Fahrenheit, I need to add another 30. So if I put it on a roof, up 1 foot degree Fahrenheit, and that will give me 102, what is it? 19, right? 119 degree Fahrenheit. Did I do it right? Yeah, 119. So my new ambient temperature becomes 119. Any question about how to use this? Any question about how to use this temperature if you put conductors exposed to the sunlight above a roof? You can't leave Dunwoody without knowing this table. Any question, guys? Okay?
What is strictly roofs though?
Commercial roof. Mostly this application for a commercial roof, most of the applications. But now with residential, it's applying to residential when you put solar system, But in a commercial roof, guys, you will have an air handling unit on the roof. Like we have a rooftop cooling tower. My cooling tower, two ways. Either you poke right underneath it and tie it so you don't put the conduit on the roof, or you put the conduit below the roof in the building, or if you put it above the roof, then you have to pay attention. When we do our field trips, you're going to see tons of conduits running on a roof of a commercial building.
Wouldn't it be hotter 26 inches below the roof at the very top of the ceiling anyway?
Nothing about it. As of now, I see your point. It will be hot, but nothing about it. No. But it's not directly, it's not exposed, it's not just the heat. Sunlight exposure, direct sunlight exposure. There's no direct sunlight exposure. Okay, any question guys about this table?
Are they using rigid on the roof?
Any conduits. Rigid, PVC, usually EMT, rigid, PVC, or any type of conduit.
I wonder what the melting point of PVC is.
Okay, we'll research that one for you. If you're doing residential, guys, remember that residential table? This is for dwelling. Can you highlight this one for dwelling if you haven't done that with Chad? You don't touch this. I'm not going to even talk about this one. This is only for dwelling. Residential, so it doesn't even interfere with my business here. What I want you to highlight is this one, Chris. This one, under engineering supervision, I can use different amps from the conductor. That's where the engineers hide behind this. Engineering supervision, under engineering supervision, conductor ampacity shall be permitted to be calculated based on this. An AmpCalc software will get you different calculations. So if you see a conductor carrying different amps, and it's engineered project, catch 22, then you can give him benefit of a doubt. Okay, so that's will leave us all the way to 310.16. I'm going to review 310.16 very quick. We talked about this one. I'm going to tell you guys, number one, this you can get it up to an insulation of 2,000. Most 99% of the time, guys, the insulation is 600. But if you have a system that runs at 2,000 volt, you can use this table too. Number one, Chris, back to your question. Remember when table to use? Look at this table. What does it say about the ambient temperature? 30. So that correlates with the first derating table, 30. And that's if that's not enough for you, you'll see another thing. So this is for conductors of the following temperature. You can go 60 through 90. So that will get you 60. 75, 90 for copper or aluminum. Make sense? And all of these are insulated conductors where 3 conductors in a raceway cable or direct buried in the ground. So you can use this table if it's in a conduit 99% of the time, if it's direct buried in the ground, or if it's in a cable. Any question guys about this table? That's a table that you're going to spend probably 90% of your time in. How do you use this table? From now on, guys, unless you know otherwise, we said, I don't know if you guys remember, we said if your conductors from here up, these conductors from here up, you default, unless you know otherwise, you're defaulting to 60, right? To the 60-degree column. From here down, unless you know otherwise, you're defaulting to 75. And what do we use this one for, guys? The 90. The rate. The only time you can use a 90-degree column is for the rating. Any question guys about these rules? We had another rule that says if the amp is equal or less 100, you use it here. If the amp is more than 100, you use it here. So if your equipment is less than 100 or less, you use 60, more than 100, 75. These are the termination. If you're doing commercial industrial, now I emphasize this in the residential. If you're doing commercial industrial, Chris, you're right here 100% of the time. Can I guys get you to understand if you're doing a commercial industrial project, 99.9% you are in this column. So the 60-degree column, almost ignore it.
So that's an and statement. Number
Or.
Number one or higher. Okay,
Or.
so I'm in a commercial project and I'm at number one or above or lower, then I must use 60 no matter what, if it's an and statement or statement.
Okay. This 100, unless there's a statement with these two, unless the termination says otherwise. Unless the termination says otherwise. Yes. Your termination overrides. Your termination overrides. For commercial project, guys, the termination on the equipment and everything is rated for 75 for the most part, 3-phase. So you're going to spend a lot of time in this area. Everybody knows that this is aluminum and this is copper, and you go through the whole deal. Any question about this table? That's where you're going to spend a lot of your career in this table. If you look at the bottom, that's to Chris again. The bottom of this table refer you to two things. Number one is the small conductor, the overcap protection device, the small conductors that tells you don't overload them, and also refers you to the derating table that you're supposed. Can you guys see that it refers you to which derating table? Like you said, which table am I supposed to go? If you are using this table, you're stuck with the 30. Why should I use this table? The question would be, why? When do I know that I need to use this table? Well, do you have any of these installations? Are you in a conduit or underground on a cable? Then you're going to use this derating table. Can you guys highlight this one for me just for a second? RHW, and RHW and R, the ones that has RHW. Highlight these for a second. Any question about these tables? Okay, so if you can, so this is the table they're going to spend a lot of time in. If you go down, guys, this table up to, so this is single insulated conductor in the air. Can you guys see that? This baby is in the air. Free in the air. So you have poles and you're pulling your conductor, you're going to use this table. Up in the air. Number 17. And Ashley, for number 17, you're going to use the same derating table. Number 18, these are not more than 3 current conductors in a raceway or a cable. This is where I want you guys. This is so-called high temperature conductors. This table talks about high temperature conductor. First, look at this. The temperature is rated, ambient temperature is 40. Can you guys see the insulation are weird now? I have a Z insulation, and I have all these weirdo insulation type. And look at the temperature is 150 to 100, 250, right? All these are weird insulation now. Okay, so let's just say, where would you use this table? You use this table inside a furnace room. Inside a furnace room. That's the application for this table. So let's take 4-aught. It goes to 4-aught. 4-aught can get me, if the insulation is this, I'm going to go all the way to 361. Chris, can you tell me from 310 to 16 how much 4-aught can give you? 310 to 16. 4-aught, how much 4-aught can give you 310 to 16 under 75? Under 75? 230. So 4-aught can give you 230 amps. How much 4-aught can give you if the insulation is rated? Let's just say it's TFE insulation. If it's a TFE insulation, can you guys see the difference? 361. 361. Okay, so let me just, not to scare you.
So when people pull that kind of stuff as opposed to parallel?
Well, no. So suppose I have a machine here. Here's my machine log. Here's another machine. And the ambient temperature right here is, let's just say 40 degree hot, Celsius, hot, okay? And I'm going to use a conductor, and the load that I have right here is 200, it's a panel, 225 amp, 225 amp, and I have an overcap protection device here, 225 amp, and a cable in between that I'm going to size. If I use THHN, I can use THHN. This is for THHN, and I can get 230 here, no problem, and derate it. But the problem of 230, guys, I have to do a lot of derating. Or I can go ahead and use number 4-aught, same 4-aught, except instead of THHN, I can use TFE. TFE conductor. TFE conductor, 4-aught, can give me 225 amp at the ends, at both ends, so the lugs are okay. And in between, it's rated for 361, so, and it's rated for 40, so I don't need to do 8. I don't need to do 8. Long story short,
So the cable TFE is also for high division too.
yes, yes, yes. So it will help you. Here's what it helps you. Very special applications where the ambient temperature is so high, it will help you to come up with a smaller conductor. Instead of derating to end up with a huge conductor, you can come up with a smaller conductor. So just be aware of that table. Can give you, but look at the insulation though, they have to be 250. They're not, THHN is not 250. So this is where, and if you look down here, Chris, it will tell you if it's other than 40, please go to the table that they rate based on 40. So they're referring you to the second table. So that's how you know which table to go to, because they tell you right underneath it. Okay, so if you, this is another table, guys, for high temperature table. I'm going to move fast through these. And then this is 3 single conductors up to in messenger. Now, if you're doing farming and you pull wire from point A to point B on the messenger, table 3, 10.15 B20 is your baby. And go all the way, guys, into, I'm going to go all the way. Okay, any question about the low voltage? That's it. Messenger, that's the wire that you carry the conductor on. The utility will give you if you look at the power line coming to your house, there is a wire that comes with them, wrap around them, or they're tied to. That's your messenger wire. Any question, guys, about the low voltage? They call them the low voltage tables. Low voltage tables. Now let's go to the high voltage table. High voltage table, guys, starts right here. Very few of you probably will deal with them. More than 2,000 up to 2001 up to 35. Look what they're telling you, guys. A few things. Number one, you can derate temperature based on engineering. You have a temperature table here for you. Or you can do the size based on engineering calculation, no problem. Can you guys see that? Engineering calculation. Or here's all the application that you can use. Remember the details? I want to flash this detail because we used it. Detail 1, I can't emphasize, Chris, if detail 1 is a duct underground encasing concrete, that duct could be PVC, rigid, EMT, no, not EMT, PVC, rigid, or any approved method that you can put underground. This baby here is one conductor cable or multi-conductor cable or multi-cables. So this dot could be 3 cables, 1 cable, or three conductors in 1 cable. The same thing for each one of them. This detail 2, detail 3, this is very common detail here, guys. I can have this could be 1 conductor or 3 conductors or cable with 3 conductors. Make sense?
So the prohibition against putting a single conductor and metal pipe goes out the window with this?
It's a system though. They're not in one pipe. They're all in close proximity to each other. And this is for high voltage too. And you're absolutely right. How can I put phase A in one? The reason why you put phase A in one duct, because phase E conductor becomes so huge, so big, that you really can't put it in one conduit. But they're in close proximity to each other. They're supposed to kill the magnetic field. You're absolutely right. What happened, Chad, to the putting them all in one conductor? We're talking about medium voltage here, higher than 600 volts. Then you can put a triplex, guys, 3 tied together. You can direct bury them. Look at the distance between them. I want you guys to look at the distance also, 7 inches when they build these bus ducts underground or the ducts. Any question about these details? These details are so important when you do medium voltage because
Why do they call it?
the utilities call it medium voltage. There's low voltage 600 or less, up to 35 medium voltage, and then higher, actually 61. Higher than 61 becomes high voltage.
What's it called between 600 and 2000?
600 and 2000. There's ultra high voltage too.
No, I mean, you just said low voltage is 600 or less.
Yeah.
Medium voltage.
Yeah.
is
What happened
2000
between?
to
Yeah.
5000.
Yeah. What happened between 2000 and less?
What happened between 2000
Still
and
over. Yeah. There is no system that I know of that's between these two voltages, unless it's special system. Yeah. The code call it, though, the NEC code call it over 600 volt. It doesn't matter. They don't use the voltage, high voltage. Utilities use medium voltage and high voltage. Okay, any question, guys, about the legend? The most important thing, this list, you wouldn't understand the tables that follows unless you understand this list. Okay, let's go medium voltage. The first thing you need to know, Chris, if you have higher than 600 volt, you can derate. All of them are rated for 40. So suppose the same thing. I have a 100 amp conductor, medium voltage, MV90, and I need to derate it based on 131. Remember that 131? If the insulation is 105, I can get 88. If the insulation is 90, I can get 84. Make sense? This derating table strictly for the medium voltage, brand new in 2011. Any question, guys, about this? Okay. If you look at, this is the first ampacity you're going to encounter, or the second ampacity. Let's just look at this one. 60.C8 insulation of insulated aluminum conductor. It triplex 3-in-1 in the air. The ambient temperature is 40. Okay, let's just say I have 13.8 kV, like I showed you guys. We're going to be right in here voltage-wise. Which insulation should I use, Chad? Default is 90. And what's the size of the equipment do I need? Say I need to size for 100 amp. I need to size a cable for 100 amp. Come over here. What's my 100 amp? Which one can give me 100 amp? I have number 4. Number 4 conductor can give me 100 amp. Any question, guys, about using this table? Triplex, and look at the voltage. The voltage is 13.8. It goes under this. If the voltage is 2.4 K, now I'm here, the same conductor can give me 90 amps. Who cares? You're looking at the insulation. You're looking at the insulation of these cables. You're looking at the insulation of these cables. Very few guys with you will be using these tables, unless you work on a major project really. But that's how you use it. This is for aluminum. Believe it or not, they have them for everything. Here's my copper, the same application, triplex copper. The one underneath it, this is in air based on conductor ampacity of single conductors. Now we're single conductors in air on poles and so forth. This one is for aluminum in air. This one ampacity of insulated 3 conductors in air based on ambient temperature, 3 conductor cable. These are cable in air. Same application. Chris, can you see that they tell you to go the rate based on this table? Because it's medium voltage, they refer you to a table if you are to go to the rate. I won't spend too much time on it, guys. All of these, you can see how different application for medium voltage. The one that I'm going to, all the way up to here, I'm going to go, so keep going all the way, different application, all the way to this one. This is the one that we use, Chris, and Phil, my friend. 310/6077, we said it's a 3 single insulated copper conductors in an underground duct. Detail, I'm going to use detail 1, which is basically 1 duct. Can you guys see that? 1 duct, and inside the 3 conductors. And if my voltage is at 12.47 K, I'm here. I'm going to use medium voltage 90, the default. And if my load, and I will use number 4 conductor, number 4 arc to carry 295 amps. To carry 295 amps.
Part of the definition of the duct is encased in concrete.
Encased in concrete. Duct encased in concrete. It could be rigid, could be any equipment. That's if you're using this wire method, though. You could use them overhead. Then this table doesn't apply to you.
I understand. I just want to make sure the concrete
Absolutely.
is part of it.
Concrete.
Looking at running a generator or something into the building,
Yes.
and you're using the wrong table. because you
Yes.
don't know what's what.
Yes. If you're direct burying it, you're going to go to a different table. Absolutely. Okay, so these are all the details, guys, that you're going to encounter. Here's detail 2, detail 3, which is, if you guys remember, detail 3 was 4 ducts. And then they go through all these applications. 3 insulated conductors in underground ducts, all of these in underground ducts, multi-conductor cable, and so forth. I think some of these buried in earth. This is yours, an Ampacity of single insulated copper conductor directly buried in earth. That's where we're just talking about. On an ambient temperature of this 20, so detail 9, now we're talking about detail 9, directly buried in air. Detail 10. I can't emphasize, guys, the ability to look at these details and understand it before you use it. Okay, so I'm going to move through these. Just be aware that these are all for high voltage. Okay, the last thing I'm going to talk about in this is the code calls it over 600 volt. Medium voltage is my term for it. All right, this is the table, guys, that gives you the characteristics of all the 600. Can you highlight the 600 here? The characteristics of 600 voltage cables. Way at the end, the construction. So if you have an MI cable, look at an MI. Let's just use an MI cable. It can be used in dry wet location, rated for 90. You can use it actually 250, rated for 250 high temperature. Here's the sizes. Somewhere here will tell you the sizes that you can get them through. Yep, here's the size that you can get them through from here to here, and a bunch of other covers that you can put in mills. This is one of the single most important tables in the book that give you the characteristics of the cables I use. I'm going to go run directly into THHN. Right here. RHH. RHH, it's rated for 90, dry or damp location, bring it on. I can buy this one from 14 all the way to 2000. So these are the insulation, guys, that you can deal with. If you want, look at this one, this insulation. What is it? PFA. You can buy this one rated for 200 Celsius. That's when it becomes high temperature derating. Any question, guys, about this table? The most common ones you guys are going to use is right here: THH, THHN, and THHW. The ones that notoriously famous. THHN rated for 90, dry or damp location, no problem. From 14 to 1000, they can buy it. THHW from 14 to 2000. Can you see how THHW more superior in terms of sizes? You can use it if you're using it in wet location, 75, in dry location, 90. And then the notoriously famous THW2, or here, this one, THWN2, rated for 90 degree, both dry or wet location, and you can buy them for these sizes. I can't emphasize, you cannot leave Dunwoody without knowing how to read this table. What I highlight, guys, THHN and THHW is the most common insulation that you can use. And did I forget to mention that this table is only they're all rated for 600 volt, all of them. 600 volt cable. Okay, so if you look at the last one, here's your UF cable, Ashley. UF is rated for 60 or 75, depending on the application that you use it. Most of the time, we use it for 60. TW, God forbid, 60. Okay, here's the XHHW. This is another common insulation that you're going to use. XHHW and XHHW2. W2 rated for 90 regardless of the location. You can buy it from 14 to 2000. Z. Remember that Z insulation? Here's my Z. I can buy a Z rated for 90 or rated for 150 for special application. And the sizes that comes with it. Any question about this table? Does everybody knows that every single insulation that we use in the US, and what this insulation house sizes are related, it's going to be in this table if it's 600 volt or less. You guys remember the SO cords? Do you find SO cord here? No, because SO is not a wiring method. SO is cable, cords. Cords are not, they're not permanent wiring methods, so you're not going to find it here. Okay, moving all the way to this. Now this is where Chris asked. If you guys look at this table, very few people look at this table. These RHH and RHW, remember I told you to highlight them later on? These you can buy them rated to up to 2000 volt. Now Chris, if you have a system that running at 1500 volt, I don't know of any system, but a special system that running at 1500 volt, then this is the insulation. This is just insulation level. It goes all the way. So RHHW and RHH and RHW, you can buy them rated to 2000 volt for a special application. And then you can use 310.15b16 to find the amps for them. Okay, so that's what I highlighted this one, and we're almost done with this, guys. This is interesting. Medium voltage. Remember when we talked about medium voltage application? Here's MV90 rated for dry wet location. 105 is also dry wet location. Both of them are rated for dry or wet location. Both these cables in the medium voltage. Thickness of insulation, not a big deal, up to 5,000. Thickness of insulation for different. Very few of you guys will be able to later on talk about 100% insulation, 133, 173. Anyway, so there's thickness of the insulation when it comes to high voltage. Just be aware of that. And the last thing I want to mention here, this is very interesting. Phil, this is the table that tells you with every system what's the minimum conductor that you can use. Take this. If my voltage is up to and including 2000, what's my minimum copper and what's my minimum aluminum? 1412. We're familiar with that. If your voltage is let's just say right here 15, up to 15, your minimum size conductor voltage rating is number two. Can you guys see that minimum sizes for the conductor that we can use for different minimum size? They don't mess with it. If the voltage, for example, if your system is between these two voltages, the smallest that you can find is 1 aught for this baby that you're allowed to use. And if you are to put a conductor in a conduit, that's the code say, and the conductor cannot be smaller. We're installed in raceways, conductor number 8 and larger must be stranded. That's where it tells you the conductor have to be stranded if they're number 8 or larger, only if you install them in a conduit. If you don't install them in a conduit, they can't be solid. Okay, conductor identification. That talks about the identification of the conductors, marking, trays. So that's basically all what I wanted you guys to look at. I want to go very quick to the conductor property for voltage drop. And I know we've touched on that one too in chapter 9. Just visit chapter 9. Where am I here? Conductor, example of ampacity. Oh, it's chapter 9 tables. Oops, I didn't do that. Any comments, any questions? Any comments, any questions? Okay, I'm going to go very quick through this because we did all these all the way to table 8. Table 8, you guys find table 5. Everybody's familiar with table 5. It gives you the cross-section area of the conductors when we size. I hope by now we know it. I just want to go to table number 5A, table number 8. Table number 8, we use it for voltage drop, guys. I want to emphasize for voltage drop, if you have number 12 here, it gives you the circular mill for it. If it's solid or stranded, all the way up to the area. If it's uncoated cover, unless you know otherwise, the resistor per ohm per kilofoot is going to be this amount for every 1,000 feet. If it's aluminum per kilofoot, the resistance is going to be this amount. Any question, guys, about the table 8 with the conductor properties? We use this one for VD, voltage drop. For voltage drop calculation, Very, very important to know how to use this table. Anybody does not know this table, we did a lot of calculation. We will continue to use this table. We will continue to use this table. So that's what I wanted to show. To show you guys. Let me see if we missed any of these conductors. So we talk about the selection of the conductors, ambient temperature determined. We talked about the copper. You can copper or aluminum conductor or cover clad. Aluminum correction factor. We went through all these. Voltage drop based on voltage drop sizes. Let me tell you one little thing, guys. When we size conductor, we size it based on three things. Number one, if it continuous load. Number two, voltage drop. Number three, derating. Can I get you guys to understand that when you size a conductor, you have to pay attention. Is it continuous load? Yup. Size-based continuous load. If it's continuous load, very easy. 1.25 times I. Okay. Then voltage drop. If it's voltage drop, we'll talk about this one, guys. Voltage drop equals 1.73 KIL over CM. So we're going to size CM right here based on voltage drop. CM is the circular mill. Derating, you guys remember what we did for derating? Derating, we're going to take the I at 90 degrees, typically, and you're going to take the I and multiply it by a factor. Okay, Chris, I have three sizes. Which size should I use then? See, I did a calculation for a load. I have three sizes. One, let's just take an example. This gave me a 4-aught. This one gave me 2-aught, and this gave me 1-aught. Which conductor should you use?
Was the voltage drop at the continuous load?
No, not at the continuous load. No. If I got the continuous load gave me 4-aught, voltage drop gave me a size of 2-aught, and the rating gave me a size of 1-aught. Which one should you use? The largest conductor. Doesn't make sense, right? The largest conductor. So please pay attention to it. The largest conductor. Sometimes we size based on largest conductor or based on voltage drop, guys. Always give us the largest conductor. Chris was running some calculation sizing based on voltage drop, and they give you a ridiculously small conductor. If you run a voltage drop calculation on a feeder, 10 feet. If you try, guys, do a calculation on a 10-foot feeder, it will give you a ridiculously small conductor. So should I stick with that one? No. You do the three calculation, and you choose the one that gives you the largest. Can I get you guys to understand that one? That's the single most important thing.
So this isn't just for feeders.
Branch circuits, feeders, service conductors, you name it. You name it. Okay. So the rating, you pick the largest. And we'll talk about this one, guys. Parallel conductor, we talked about the rules for parallel conductor. When you parallel conductors, you put them on the same conduit because of induction heat. Medium voltage, you are allowed to put them in ducts underground, but in close proximity to each other. In close proximity.
The voltage drop thing, if you're building a system within a machine, for example, do they use the voltage drop, where the NEC rules don't exactly?
UL also, engineers of UL take consideration for voltage drop.
Yeah.
Absolutely. You're expected
You come up with these ridiculous numbers. Let's just say you're only going to go 6 inches.
Yeah, but they use the amps, the continuous load. You use the formulas, and you choose the largest one.
All right. So is there some logic that tells you when the number is ridiculous?
Yes, if it's here, take this. When it's ridiculous, take this. Where's the one that the calculation we did? Did we lose it? Correction factor. Anyway, the calculation that we did, if the continuous load give me 4-aught, can I go to 1-aught? That's ridiculous. I can't go lower than what.
No, I mean from a practical standpoint, will the conductor burn, or will it just violate the code?
Will the conductor burn? It could burn. I'm not going to tell you it would burn. It could burn. When we parallel conductors, guys, you know how each phase is? Here's the three ones. You take three conductors, three conductors, three conductors. Phase A, B, C, and a neutral and a ground in every conduit, right? That's typically how we size them. Phase A, B, C, and a neutral in every round. Those are for those of you who are going to be a project manager. They have a device, mega ohm meter. Before, in major feeders, guys, before you energize and blow up a switch gear or burn equipment, they have a mega ohm meter. They pump voltage across conductor, his phase A and phase B, and this should show infinity. The amount of voltage between them should show infinity, meaning they're not touching each other. They call it continuity testing. Continuity testing, it shows that these two conductors are not tied to each other. Again, from the load side, you disconnect them from the load. And then they take this and they tie it to the conduit. They take phase A and you tie it to the conduit, and it should get you a huge amount of voltage, infinity, meaning your phase A is not grounded. You do the same thing for phase B, the same thing for phase C. And then you go phase A, B, A, C, and then B, A, and then A conduit, B conduit, C conduit, neutral conduit. And then you do it between the neutral in every phase and the neutral of every and every conduit. By doing it this way, you're guaranteed, especially on feeders, major feeders, not branch circuits. You talk about 225 amp panels on higher. Typically, you measure them. So that will give you, if you have a short circuit, you will know about it before you energize and blow up the fuse. That's what this is supposed to get you. Talk about the wire gauge and how they do it with the dies. You guys read that in your own. That's all I have. Any comments, any questions? Any comments, any questions? This is, if you graduate from here, guys, 310, Article 310 is must know. The stuff that I told you. The low voltage, you have to know it. The medium voltage make you better than you never, if you know it. Or the higher than 600 volt. Any question for Chad? That's all what I have for you.
Isn't the medium voltage a typical supply of an industrial project?
Supplied by? Not necessarily. You go to 3M, they own and operate their medium voltage. The U of M own and operate their medium voltage. The major
outside building, I would guess.
Yeah.
Here, I think they said
Mayo Clinic own and operate their medium voltage. I know a few customers, but they have to be big. You're right. I would say 90% of the owners, I hate to throw that number, 90% of the people that you deal with buildings are actually dealing with 600 volt or less.
So 480 systems.
Yep. Yeah, mostly 480 in the US, 480. Only 10% of customers, big customer refineries and all those guys, they make probably 10% of overall utility customers, but they consume a lot of power. Those guys, they give them higher than 600 voltage, typically 1247, 13.8, 4160, and so forth. Any comments, any questions? I hope that was good, guys. Good